you'd use the chmod command. They call it change mod.
Mhm.
Okay, that would basically give me read write, but not execute. It would give everybody in my group no permissions whatsoever, and everybody outside of that group no permissions whatsoever. Okay, so the grouping of the three RWXs is basically you, the permissions for you. Your the middle group is your group, because everybody, you know how in Windows, in Active Directory, you have a default group, and that's usually domain users,
Mhm.
and you can't leave that group. You can't take someone out of the domain users group because that's their default group. Okay, this is something that comes over from Linux over to Windows, for what they call POSIX compliance. Right, I'll talk about that in a minute too. All right, and so the last group here is for everyone else. Okay, so if you remember, if you got to remember that grouping, when you look at permissions, you look at them in groups, in each separate group. The first group after the dash or the D, right, is you. Those are the permissions for you, right? Then if your primary group is local administrators, right, that's your group, and that's the middle permission. Everybody you work with, everybody that has the same permissions on the system as you, okay, is in your group of users. And then the last one is for everyone else not associated with you that might be using the system, okay? So you got to remember something here, that what I talked about a second ago about POSIX compliance. Now you could Google that, okay? But let me explain what it means. POSIX stands for Portable Operating System, okay? And back in the 60s, I believe it was the OSI, it was either the ISO or the OSI. I think it was the ISO, the International Standards Organization. Remember the OSI model, right? The ISO made the OSI, is an old joke. The POSIX compliance basically means if your operating system is POSIX compliant, it means it has a couple of things that are common to all POSIX operating systems, okay? And one of those things is, number one, it's multi-user. And it'd be good if I could spell. I need Tom to do my typing for me. Okay? It's also networked. Okay? It means out of the box, this operating system knows how to speak at least one protocol to be networked onto a network system. And it might not be TCP/IP. It could be any number of different protocols. But the idea is that you can share files over a network, at least locally. Okay, and we're talking minimum compliance for POSIX compliance. Okay, finally, it's got internal security. And file level security. Okay, so the original version of MS-DOS, okay, that shipped with the original IBM PCs back before they made dirt, right? That was not a POSIX compliance operating system. And therefore, most of the computer world back then kind of laughed at it and thought it was a joke. And that's why HP agreed with Bill Gates to allow him to sell his MS-DOS system that he leased out to HP and IBM. He made it into his contract that he can go in and sell that operating system himself, and they laughed and said, "Yeah, but who would buy it?" Okay, and basically, it sold a few copies, but he basically gave it away. If you took the 3 floppy disks that MS-DOS came on, it was easily even uploaded over a phone modem connection. Okay, so it got around. And it was on the IBM platform, which started with a Texas Instruments chip, and then moved on to Intel later on and AMD. That PC system, not talking about Apple or anything like that, but the basic first PCs, most of them ran MS-DOS. Some of them had an early version of Windows on it, Windows 3.1, 3.11 for work groups, and that was technically a POSIX compliant system because it was by its very nature multi-user. You could have more than one user account on it. It was networked natively, and it had internal security, meaning number one, you had to be able to log into it. You couldn't just access it without if you wanted to make it open, it could be open with no password, but you had the option to password every user account, and plus you had the file level security of the early NTFS file system, which we know today, and we're very familiar with. Now today we've got a new file system that kind of supersedes NTFS, and that's what is that called, Scott? RTFS or something like that. Is I forget what it's. I forget the acronym. It's not used a lot yet, but it has a possibility of becoming quite famous or quite popular because it takes the security to a higher level. But going back to Linux, back in the 60s when the first Unix system was made by Dennis Ritchie, and I forget the other guy's name, over at AT&T Bell Labs, the security system, the security setup of a Linux system is so damn simple. It's almost elegant. And it works, and it's secure. And as simple as it is, it still provides better security than just about any Windows system. Windows systems can get very secure, but you need a lot of third-party plugins and things like that. Where Linux out of the box and Unix, its older bloated parent, Unix is basically like what a supercomputer would run. Okay. I just wanted to to share that. So like when you're looking at this odd operating system that's running under ESXi, you're basically how should I say, you're looking at something that is going to be the same operating system across the board on a Macintosh, on if you can get to a shell to talk to an Android phone, same stuff. And you're going to have things like the VI editor on every one of those platforms. Now, yes, there are better, newer editors, but you're going to see VI on every one of them. It's always there. That's like their notepad. Okay, so let's go back. I wanted to show you guys something while I'm sharing my screen, and I'm going to right click on this and go to properties, right? And this is file folder. Oh, can't get it from here. I'm going to share this. Hold on one second. I'm just going to unshare my screen. And I'm going to drop something in the chat. I want you to create a folder on your desktop of your Windows machine. Okay. And find it here. And you're going to name it exactly this, what I'm going to copy and paste into the chat. I don't know if you ever heard of this. It's called God mode.
Got it. And that new file system is called Resilient File System, REFS.
Sorry about that, guys.
Oh, okay. What happened?
My team's crashed out.
That file system is called Resilient File System, REFS.
I couldn't think of the name, Scott. I'm so terrible sometimes.
Gemini AI says everything.
So if you if you look into the chat, let me go back to the chat. Hold on a sec. Come on. Here. Okay, you guys got that God mode thing in the chat?
Yeah, I got it.
Okay.
It's already on the server.
Okay. So if you make a folder on the desktop called just that, and you open it up, you're going to see it opens up like a file explorer thing, but it's got all these different shortcuts for managing your Windows machine that you could otherwise find in other places, but it puts them all in one place, which is kind of neat. And you see under the right here, under applications, kind of like what it's subjected under, right? Everything, your mouse, your network, your power options, programs and features, region, security and maintenance, sound, system, you name it. And it's a lot of stuff. I thought you might find that kind of like a fun little thing.
Very interesting. Where did you get that? Don't mind me
I've known
asking.
about it for a while. All right. So what I'm going to do is I'm going to stop sharing and let Scott take over back with sharing on his machine. Okay. So you're when you got into that ESXi system. Okay. So what I'm going to want you to do is I'm going to put a command into hold on a second, just got to find it. The put a command in that will list your virtual machines. Hold on. So I had the wrong window open. Okay.
Now, this is a VMware command, correct?
Yes. Okay, I'm going to put this in the chat for you, Scott, and for everybody else. Okay, VIM-CMD space VMSVC / get all VMs. Okay, so you want to put that in your putty window. Okay. And look at that. It lists the two Windows machines and the Kali Linux machine. Okay. Now, the one thing I want you to note on the left hand side, the far left hand side, the VMID. Okay. So let's find out what um, ESXi says about the power state of these machines. Okay. Now check out that next command, Scott. Without the brackets around it, you're going to do the VM svc slash power dot get state and then type in 4 for your Kali Linux machine. Is that running right now? Well, how about this? We're going to find out.
Wait a minute. Yeah. Let me see here. So same command, but get
Basically,
state, right?
yep, power dot get state.
So
So you hit the up arrow, right? And yeah, instead of get all VMs, you do power dot get state and then the number 4. Right? So you can see it's powered on. This would tell you whether or not, obviously, whether the machine is powered on or powered off. Okay. Now, you could either power on or power off that or any other VM with this command. And obviously, if you wanted to power off, you could do power.off instead of power.on. All right. So you want to try that and try to turn the VM off from here. It's Linux.
yeah,
Nothing will hurt
yeah.
it.
Hold on. Yeah, right. Hold on a second. Okay. All right. So we're gonna say like that.
Yep. Okay. So let's give it a second for it to fully power off. And if you hit the up arrow to go back to the get state command, right, and hit enter. See, and now it's powered off. Pretty cool, right?
Very,
Now,
very.
we'll definitely we'll go deeper into this as we go. But I don't want to how should I say, like weigh you down with a lot of different things. This should if you headed, let's say, this is a message for Tom. Tom, if you headed over to, let's say, Patriot, right? Because Patriot's ESXi server's web server is broken, right? For some reason, we can't get that thing to start, right? So you go up to the console and get the way you can if you're sitting in front of the ESXi server, right? Here's something to remember and to put in your notes too. Okay, if you're sitting in front of the ESXi server, you've got the ESXi like dashboard on your monitor. You can log right into the shell by hitting Alt F1. That will switch over to the SSH window and then, of course, ask you to log in as root. It'll automatically try to log you in as root. You type in the name root and or any other name that you set up on the system and then the password. And you basically on the server would be looking at this exact same screen without doing it remotely. And these commands would be the commands you would say, okay, give me a list of all the VMs, right? The get all VMs, right? And then you wanted to see the power state of the VMs. I think, Scott, if you do get power state without a VMID, right? If you go back up to the get state command and just take off the VMID number, I'm not sure if you could take off the VMID number, if it'll just give you all of them, right? So try it.
I tried it here. I don't. Did I get it? It said it was invalid.
Okay, you might have to do star space star. okay, or space instead of the star, maybe all. I know there's a way to do it. You can Google it, right? There is a way to just show you all of them, but you could just go through them and just change the numbers. You in your case, you've got 1, 3, and 4, right? So if you go, to change that all to 1, then hit the up arrow, then change the 1 to a 3, then change the 3 to a 4. It that's the way I usually do it. I remember there was a switch that you can put in there that hold on, get state, right? This power dot get state. Sorry.
See if it does all.
Yeah, try it without.
Ah,
There you go. Right. Retrieves the power state of a specified virtual machine, not all of them. Right. So
right. So you would have to say do one at a time.
yeah, like I said, I know there's a way to show that like all of them for it to go through all, but you'd have to Google that one. I don't recall it off the top of my head. So anyway, neat stuff. Okay. Um, let's go back for a second.
Let's see.
So what I don't understand is that it should show you your data stores on
There
that
you go.
LS, and
There
it
you
should
go.
show you like the root directory where your VMs live. Um, I have to look at that closely, a little bit more closely. If you could do me a favor and just where you are right now, just do an ls space minus L. Let me look at that a little closer. What is your data store called?
Well, it says it right here. Scotland Lab. Check
Data
the.
store 1, right? So it's data store 1, right?
Yeah.
And I'm wondering like why it doesn't come up here. It should. Um,
Let me look in the. Let me look in the GUI.
yeah, go ahead.
So the data store.
It might be store, maybe.
What is the data store manager?
You do a
Yeah, it's data store 1. I see.
yep, it says it right up there, but it doesn't list it on your list LS.
Could it be in a directory?
Well, we tried boot bank. It's definitely in a directory, right? So I'm looking at that. The might be in the I don't know why it would be called boot bank or alt boot bank. Um, try CD space store. And then do an ls minus L.
Zip.
No, nothing.
I
All right,
wonder if
so
it's in VMFS or VMI image or VM images maybe.
it's CD space dot dot forward slash dot dot. No space. Okay, hit enter. Okay, and then type in ls space minus L. Let's okay. So PWD, we're back at the root, I would imagine, right?
Yep.
Yeah. Okay. So try we got to something we've got to figure out like where the actual machines are stored because it's data store 1, but why data store 1 isn't showing up here is I don't know why. It should be here. That's a separate physical hard drive, right?
No, that's the internal drive.
But it's separate than the boot drive, right?
I don't think so. I think it's all in the same. I only had one drive in there. I think it's a terabyte. There is a volumes that has all your mounted data stores in there. So if you went into VMFS volumes, I don't know if that would do it.
You could try it.
Yeah, I'm gonna say it might be right. CD. I think it's dash VM. Okay. It could be wrong.
Oh, there's data store 1. CD space data store 1. There it is.
Oh, you see it?
Yep. So do CD space data store 1. You misspelled. Yeah.
Yeah. Try spelling it right. Data store. I say that all day. Okay.
Now do an LS space minus L.
There it is.
There it is. Okay. So I just want to show you some like the difference in between the LS with the different switch with the switches. Okay. Do an LS with nothing. Just LS and enter. See how it lists it? So every time you look at something white, okay, that's a file. Anything blue is a directory. And anything yellow is a system, a system file, right? So that's it's got, Linux has nice color coding for things like this. Okay. So you, the ls space minus L, let's take a look at your Scotsoland lab, right? So CD space Scotsoland dot lab, dash underscore lab. And of course, remember that Linux is case sensitive with everything. So, you got to make sure that you're always, wary of the case. Okay. Now, I want you to take a look. This is all the files and the restore points, the snapshots, all that stuff for your particular virtual machine, right? Notice the VMDK file, which is huge, right? Look at the size of it. It's about the fifth one down, sixth one down, right? So you see the Scotsoland lab dash flat dot VMDK. That's your C drive. Okay. And what I also want you to take notice of this yellow file, the one that says .vmx. Okay. That, remember I told you that when you move a VM from one ESXi box to another, right, that you want to remove all references to the networking.
Right.
Okay. There's the VMX file is actually a text file. Okay. So we don't damage anything. I want you to CP, that's the copy command. Okay. Then a space. And then get the name Scotsoland underscore lab dot VMX. Okay. And you're going to space Scotsoland underscore lab dot Scott. Unlike Windows, file associations, there's no file associations basically, unless you write them into the shell, right? So it doesn't work the same way like a TXT file. You can call it a TXT file. You can call it a Scott file. You can call it a Fred file. You can call it anything you want, okay? That's going to basically just copy that file to another file. And the reason why we're doing this is so we don't fuck with the actual VMX file. The VMX file is the file that ESXi will read as it's booting up that machine for all of its settings that you set in the graphical user interface, which you could also set in a notepad. Okay. So if you hit enter on that.
Why is there a tilde next to the other one?
It's a what you call it, like a standby test, like in case the one file gets corrupted, it's got the backup.
Gotcha. All right, we're making that file.
Hey, do an ls-l, and you're going to see the scotsoland_lab.scot file. See it? Okay, so let's whip out our old friend, the VI editor. So type in VI space scotsoland_lab.scot.
Oh, I see it.
Okay, and as I told you, this is the VI editor. Okay, so the VI editor has some weird idiosyncrasies about it. Most notably, that to type into the file, you've got to hit the lowercase I for insert. Uppercase I does insert at the beginning of the line, and I forget what does insert at the end of the line. We're just going to go, and I want to show you something. If you use the arrow keys and you go down and you look for a line that starts off with Ethernet, I think it is, right? See Ethernet 0. There's a couple lines there, right?
Mm-hmm.
Hit lowercase d.
Right there where it is?
Yep. See, it just deleted it?
Yeah.
Right? Do that until you have no Ethernet zeros there. Okay. Now, right there, hold on. Okay. And see, if you look down, you've got another Ethernet 0 down towards the bottom.
Yeah.
Right? DD that. That's DD means delete the entire line. And let's keep scrolling down and look for any other Ethernet entries. So what we're doing here is we get rid of any Ethernet mentions in this file. So when it lights up, when this thing boots up into another ESXi box, you get to tell it what network cards it'll talk to from there. And you do that in the graphical user interface once you get it moved over to the other server. This is what I did over at Astro Electroplating to move the virtuals from the old server to the newer server.
I think that's everything.
Now, to save this and to exit out of the VI editor, you're going to hit the escape key, then a colon, that's the ... And see, now you got the cursor down at the bottom with the little colon down there?
Yeah.
WQ, lowercase w, lowercase q, right? That's for write and quit. And hit enter, and you'll see that we'll be back at the shell prompt. Okay? Now, to prove what we just did, you can, in Windows, you would use the type command. Let's clear the screen.
Right. Is it clear?
Excellent. Yep. Okay. And now type in cat space Scotsoland _ whatever it was, lab.scot, right? And if you hit enter, that's in Windows, that's the type command. In Linux, it's the cat command. Cat stands for concatenate.
Yeah.
Okay, so that's how you would prepare your ESXi VM to get moved to another server. Basically, it strips off all all of the Ethernet stuff, and the only thing you're bringing over is the references um, to the actual files. Now, in a couple of places here, you'll also see that there's some paths that literally point to where where it can find the hard drive and stuff like that. You would have to change those as well on the new system once you got it over there. Okay. Any questions or rants or raves or anything?
How would you? So aren't if you're emulating, if you're just moving over to another box, aren't
Yeah,
the
this
directories
is
relatively the same?
what's that?
Aren't the directories relatively the same if you keep naming everything the way it should be?
Do a PWD for me.
Okay, hold on a
You
second.
you you could clear the screen and then do a PWD. Right? You see that like that randomly generated folder name,
Yeah,
right?
yeah.
It's also going to be randomly generated on your other machine.
Oh,
So if it's so anything that's pointing to the old directory structure, you would want to make sure you knew the new directory structure. Like keep that like in your notes in like Notepad on your machine, and then you'd copy and paste that into the file. And yes, you can use copy and paste from your host file into the session. That does work because everybody knows how lazy I am. Uh,
mm,
and so, typing out that stuff. See, Tom has got like he's got the ability of being able to type like a madman, like a 1960s secretary. Um,
it's
no, it's an amazing talent that you actually know how to type. And me, I mean, I can type kind of fast, but like he like actually knows how to type. So
mm,
he might be inclined to like type out that directory name and get it right on the first try. Me, I would have to rely on a little copy paste action.
mm, nice.
So, Tom, any questions? Yes, yes, yep. Now that was in Proxmox actually, which, by the way, is also Linux, right? So, yeah, it's the funny thing about this stuff is when it comes to anything with VMware, you'd be surprised how handy it is to be able to go out to the command line and make these adjustments rather than fiddle around with the graphical user interface in a web page. So just so um, um, just so I want you to like kind of like everybody to get used to like just have a familiarity with doing this so that if you ever get tasked with doing it like on the job, you've got a little bit of a level of how should I say a level of comfortability that you feel like, yeah, I've done this before. So of course you want to do this on your own lab, set up VMware and install it like on a PC. And Scott was telling me today that he found some deals on some Dells that were like what 13th gen i5s that had quite a
Yeah,
few cores in it. Yeah, I'll let you tell the story, Scott, because
yeah.
you know what you're
Got
talking
a
about.
couple. Yeah, 32 gigs. I think it's 512, and they're like 13, 14 core machines. So I have a 7090 micro, and I have an Ace Magic i9. It's like 24 cores. Thing is sick, but it's like no bigger than a box of cigarettes. My plan is I have a Plex server in this house, and everybody in the house watches every bootleg movie known to man. So the thing is, I noticed like the power on the Think Center, it's getting a little much. I'm like, yeah, it's raised my electric bill considerably.
It's got
I bought these.
dual power supplies, right? And they're probably like what, 400 each.
No, this is the Think Center. It's the 970. It's the old Andrew Reed machine. I still have that. It's dying, but I still have it. But it's a power pig because it's a desktop, but it's these smaller optiplexes and these smaller footprinted machines have less power draw, but they have more processing power and RAM in them than that machine.
There you go.
So what we're doing on here, we are in a precision 3430 small footprint, small form factor machine that has 8 cores, 16 threads, and I think it's got 32 and a terabyte hard drive on it. That's going to be my biggest machine. This ThinkCenter is out of here. If anybody wants a Plex machine, you can have it.
Yeah, that's
Um,
one. Just so you know, guys, one of the things that Scott built was a like one of those like systems that serve up movies on like to any TV, smart TV in your house. Pretty fucking cool.
Oh yeah, I have it on. I have it running on two networks. I have it on my main network. I used to have it on my main network. Well, I still have it for me, but I have it on my IoT network too, because Plex lets you split it per network. So I split it across two networks, so I could put it on a guest network without having anybody access my main network.
And check
But
this
the
guy out. That's
machine,
his house, guys.
yeah. Well, yeah, I was trying to break everything up because you and Bricka told me about that. Like don't have everybody on the same network. If you're doing something, it's gonna slow you down. I
Yeah,
mean,
Tom,
my
remember I told you about Dave Bricka, the best tech I ever met?
Yep, yep.
Yeah, Scott works with him every day.
yeah, that's my
Oh,
boss.
oh shit.
So what I did too, like this printer, I have it running on the guest network and I have it running on the main network, but I use it wirelessly on the guest network. But on the main network, it's got an Ethernet and I plug it into the switch. And I'm running on two networks. This way you can print wherever the hell you want, as long as you don't print where I'm working. I try to keep everybody off that. This network we're on, we're the only ones on here. This is where all the magic is, but everybody else uses the IoT and the guest network in the house. I just I just feel it's a better way, and plus it taught me a valuable lesson. When I started doing this stuff. I mean, I may not be a Rhodes Scholar on it, but I know enough to get around. I can bullshit my way through a party with no problem.
Okay, speaking of partying, I want to show you, Scott, something that I showed my guys at work.
Hmm.
Um, but I don't think I've ever. Have you ever used the winget command? Is that something you're familiar with?
Never used it. No.
Okay, I'm going to show you something kind of neat. Okay,
Okay.
if you go to minimize this shell window, right, and leave it open, but open up an elevated command prompt. Let's type in winget, one word, and hit enter. Okay,
Hmm.
it's there. Okay. Anything Windows 11 Server 2025 has it already. You can install it if you don't have it using a PowerShell command. You can easily find that on Google. Okay. Um, Now hit the up arrow and retype winget, and then do a space and then upgrade, one word. Hit enter. Now it's really neat. Hit yes. Just say that you trust this repository. Okay. It's going to give you a list of everything you have installed on your machine and the version that you have and the version you can upgrade to, right? And what's cool about this, and Scott, I know you're going to like this, especially for doing workstations. So like, let's say you're going to do a workstation and deploy it out to, let's say you're going to take that image and clone it and make that multiple images. You can literally update like everything, even third-party software. Okay, so look at that Google Chrome. It's got an upgrade for you there, right? So all you have to do to upgrade everything is hit the up arrow and add to the upgrade space dash dash add. and watch it go. Oh, how do you do that? Hit the up arrow one more time. No, dash, not dot, dot. Space. Add. No space after it. I'm sorry. No space after the
Sorry,
dash dash.
I muted myself. Sorry, hold on. Okay, what is it? Okay, like that, right?
Yep.
Okay, now, oh, why is it not doing that?
Clear the screen and hit enter a couple of times. Okay. Hit the up arrow until you get it again. Right. Upgrade dash dash add. That is the right command.
Sure, it's not one dash.
No, it's two dashes.
The permissions thing?
No. You're elevated.
I don't see add in the options. I could
No,
be wrong.
and you're not. That's the funny thing. It never show. It doesn't show up there.
Oh. Accept packaging? No.
No, it's dash dash add.
Huh.
Let's try it in PowerShell. All right, run as a admin.
Okay.
Space upgrade.
Yeah. Huh. Hmm. Okay. See if that's the right command. Oh, you have to all.
All.
Mm-hmm. Yeah. Well, it's
Try
gonna show
all.
you. Boom.
Oh, that was close.
2 letters. That's gonna be.
Hey, it's
That's
pretty
not.
cool. It does. It downloads the upgrades, and it. What's cool is that it even does the third party stuff. Not add, it's all. Dummy.
Yeah. Yeah, because you're saying upgrade, and it's gonna ask, well, what are you upgrading?
All. Right.
There you go.
Yeah. When you think
I
about
can't.
the syntax, that's exactly right.
I can't believe I even knew that. Okay, so
Logical.
yes, flawlessly logical. All right, so this is downloading. Yeah,
Yeah,
so this is
it does its own thing. You can minimize that.
sure.
For sure. Okay.
Oh, it's doing
Now,
something.
what I want you to do is, yeah, it's going to open up Windows 2 as you go. Okay.
I wonder if you could do that silently.
I want you to check something really neat. Okay. Here's like a website that I found. You're going to like this. I'm going to put the link in the chat. Right. And if you guys can follow along with this from on your own machines. Open up that link that I just sent you.
Oh, oh, I think I know this. Yeah, I think I know this. Yeah, I know this. There's a whole course on this.
Yeah, it's pretty fucking cool.
It's it's
So
it's very elaborate, and if you get certified in this is big stuff.
it is pretty cool.
Mm-hmm.
Um, one.
No, it's me.
It even has dating. Oh yeah, it's much better. The light mode is much easier to see.
Mhm.
I think if you go to IP and MAC address, I'm pretty sure it's in there, right? That opens up. Let's see, host port discovery, second one down. Okay, and that one of the things that it can take you to is Nmap, right? So jump over to that and say open Nmap, right? And you can download it right here for Windows and Mac and Linux. Okay. And don't get the RPM. You want to go down to Windows.
Oh, that's fine.
Yeah.
Okay. Is this what am I doing this way?
It's
What
got
the hell
it's
is
got the
going on?
Windows exe in here somewhere.
Is this it? NCAT? No,
Yeah.
I think
Latest
this is
uh
it.
latest stable release, the Nmap 799 setup. That's it.
Okay.
Okay. You download that, and once you install that, Nmap is a neat little hacker tool, but it's also good for us system administrators. And I'm going to show you some neat things you could do with this. Basic things, but neat.
We want to do any of this?
Let's see.
Leave it as is.
Yeah, just as it is. And it's going to do a separate installation for the NCP cap, I think. That's for USB stuff, which is cool too. You could definitely install that if you want. Okay. So now if you open up an elevated command prompt, and I'm going to show you this command with with some how should I say um, let's do um, a quick scan of Google's DNS server, right? So you just type in nmap space 8.8.8.8. Okay. And what it basically does is sits there and says, okay, I checked some common ports, and notice that that is Google's DNS server, right? So what port is DNS? Obviously 53,
53.
right? And it's got HTTPS, which is 443 that's open.
Mhm.
You can actually, this actually has a website that you didn't know that.
Oh, what?
8.8.8.8.
Oh yeah. Well, I don't know
And
that.
also it's just used as a DNS server,
Mm.
right? And that would be on port 53, right?
Mm-hmm. Ah.
So this basically shows common stuff that's open, right? That basically you're what you call it? I've got the IP address of one of my Fortinet routers, right? So you can go back to there and do an Nmap, and then I'll give you the IP address. It's 24.157.50.234. Right now, this is a VPN firewall, right? So you're going to see a few things open on there. So run the Nmap on that.
Mm.
Okay. And you're going to see that it's up, right? It's got 443, HTTPS. It's got 113 open as ident, 451 open as UUCP logon, right? That's for
Mm-hmm.
the that's one of the open ports for the VPN. 80 HTTP is closed, right? The ident is closed at 113. HTTPS is closed, but you can open it. You can actually log in from the outside. I only have that open. I opened it for this lesson, and I'm going to close it tomorrow. Okay.
Mhm.
But I just wanted you to see this this Nmap is a neat little tool to basically do like host discovery. You could do a port scanning of like all ports. So if you change that, and it's going to show you basically the same thing, but I'm going to show you if you hit the up arrow and you Nmap to the 24.157 address again, in between Nmap and the IP address, if you move the cursor to the left and to the middle there, do dash lowercase s space, yeah, pardon me, space
Bless you.
lowercase s uppercase s. So you SS,
Like
but
that.
it's no space in between them. Right, just like that. Now that's going to tell you to do like a complete port scan. Okay, so you could run that. And it's basically going to show you the same thing because those really are the only ports that are open.
Mhm.
But you could also do that to like any other host, like on your network. Um,
Hmm.
Now it'll also do a service detection, um, and you could do this, let's say to 8.8.8.8, right? Instead of SS, you do you do Nmap dash lowercase s uppercase V as in Victor, and then point that at 8.8.8.8. And that'll show you services and versions of those services that are running on it. Usually takes a little while. But also got to remember that that's Google, and they've seen uh, service detection too, so they might be blocking it. Okay. And basically, you're going to see 53 and 443 is your two services there. I think you could hit enter once again on that just to kick it into gear.
But yeah.
Okay. So your some useful options you might find for that. I just put into the chat.
Oh.
Nmap with no switches brings up the help screen. Lowercase s, uppercase s, SV, we did that. O, it actually tries to detect the operating system. And dash P dash will do a scan of all ports. And that's aggressive. And like I said, Google will probably get pissed at you and close the session down. Stand up for a second. You get to a certain age, you can't sit for a long time. Your body feels like, okay, you need to be unfolded.
Yeah. Let me do that. Let me actually walk.
Okay. All right. I wanted to change the mood for a little bit. All right. We've got about a half an hour left. I wanted to talk about the subject of subnetting because I promised when I sent out the invite that I was going to talk about that. All right.
Yeah.
So, Scott, do you remember the what you call it, the three different rules or equations that we use to figure out subnets?
There was the two. Oh God, I used to know these too.
You should be an
Uh,
ace at this.
I used to be good at this.
Yeah, when you don't do it every day, you kind of forget it.
That's
I
why.
had to actually sit there and like write some notes down.
Uh, but and the formula subnets equals 2, and then there's the variables. I remembered usable hosts 2h minus 2. That I remember.
Right,
I
right.
think I
Okay.
had to look that up. I'm sorry. Variable is
It's okay.
h is the number of host bits, and then doing this block size.
Right.
Uh,
Okay. So let's talk a second about this, okay? If you're dealing with a subnetted network, okay, you're going to be dealing with smaller networks. They're not going to have 256 254 hosts on the subnet. When you look at a subnet mask, okay, of 255.255.255.0, that dot zero at the end basically unmasks for hosts on the network, um, 254 possible hosts. Now, there's actually 256 numbers in there. When you consider that zero is a number, but we're not including that because zero can't be a host number, right? And 255 is a number in that range, but we can't use that because that's the broadcast address for the subnet. Okay. So
mhm.
in between, when you consider 1 through 254, you have 254 possible hosts on a normally subnetted Class C network. And when we say normally, we call that classful. Okay. Classless is when you break the rules and don't go by that, right? So if we're talking about classful networks would be a 10 dot network would have a subnet mask of 255.0.0.0, which would enable, I got to go back to my subnet calculator. Um, I think that'll enable like 66,000 hosts or somewhere around there.
Mm-hmm. Oh, what happened?
Let me
Oh.
just let me just go take a quick look because I do have a subnet calculator and I could just look that up.
You can actually calculate an NPS too. It does it.
Right? Yeah, so that would be 254 hosts. But if you go down and you go all the way down to a 255.0.0.0, that is 16,777,214 possible hosts. Now, here's the question. Why would you never want to build a network like that?
This could be breached
No,
easily.
no, that's not the answer. But
Okay.
good guess.
Oh, I
Here's
guess.
the answer that you probably that like you don't realize, but you deal with it every day, but you don't realize it. Okay. Windows has a problem with TCP/IP in so much as when it talks on the local area network, it tries to wrap its mind around or tries to enumerate every possible host. So if you've got 16 million possible hosts that could be on the network, just browsing the network and going to, let's say, look at the shares on your server is going to take forever. You're going to think something's broken because
Could be
there's like,
scanning.
yeah, it's like in the background, Windows is going to be like, wait a second, I've got to make sure that I wrap my head around every single possible host, every single possible combination. And it sits there and it eats up memory and it tries to do that. Okay.
It's like that guy that's got to be invited to every party.
Good analogy. Okay.
And if I'm not invited, I'm going to eat every piece of food there. Okay, got it.
It basically it crashes out the system.
Yeah,
Okay.
it annoys people.
Linux doesn't do that, but Windows does. Okay. So, and also, you think about it. Here's another problem with having a big network. Um, it's it's a security problem in so much as, let's say one of your hosts gets a virus that is one of those kinds of viruses that can easily hop from PC to PC. You don't have any segmentation. You can't isolate, right? So what a lot of companies try to do is they build subnets and they make them as big as they need to be, or maybe a little bit bigger, right? For the hosts and the printers that are on that network, okay? So in the case of, let's say, a simply subnetted network, let's take a subnet mask of 255.255.255.192, okay? Now, if you look at that in binary, it kind of looks like this. Scott, if you wouldn't mind, yeah, put it up on the screen. You can make that font a little bit bigger too, if you wouldn't mind. Go to format and font, and just make that like 20 or something like that. Yeah, it's just a little bit bigger, right? So on the next line, hit enter and do that in binary, right? So it's 8 ones. Nope, ones. Dot, yeah, dot, same. And then the last one's going to be 1 1, just 1 1. Nope, nope, nope. Back off. The last octet is only going to have 1 1 0 0 and then 4 more zeros. Right. Okay. So that's what that mask looks like in binary. And that is important to visualize, because what a subnet mask basically does is it masks off part of the IP address from what's underneath the ones is, or I should say, what's covered under the ones is the network, and what's covered under the zeros is the hosts on that network. Okay. Now, if you figure this out, okay, to say, okay, I want to do that subnetting, how many possible networks does that allow for? Okay. Well, it's pretty simple. You have 2 bits that you're borrowing from the hosts. So with 2 possible bits that you could use, with binary, you've got 2 characters um, and 2 places. That's 2 to the second. That's 4 possible networks. Okay. So the way this works out, and the way you can figure it out really easily, is the number of hosts on each network, the number of subnets that you're going to uh, um, uh, come out of this, and the block size. In other words, the jump that you're going to make from one subnet to the next one to the next one. Okay, and I'll explain. So the first thing that you're going to calculate is 2 to the B, right? 2 to the borrowed number of bits. So 2 to the borrowed number of bits. In this case, we're borrowing 2 bits. So that would be 2 to the second power. So what's 2 times 2? That equals 4, right?
Correct.
So there's going to be 4 subnets. You just put equals 4. Okay. Now the next line, you want to figure out how many um, hosts on each subnet will we have, right? So that's pretty easy, because you got to remember that you've got the first number is going to be the network. The last number is going to be the broadcast. We want to figure out how many hosts are going to be on each network. So we go 2 to the H, which is 2 to the host bits, minus 2. And that minus 2 takes away for the network and the broadcast. And in this case, that's 64.
How do you figure?
Sorry.
I'm sorry.
Sorry, that would be 62.
Right. So would be 62 hosts.
Right. So where do we get that from? How many zeros are there? There's 6 zeros in that subnet mask. So 2 to the 6th is 62. Okay. Now we want to figure out the block size. What are the jumps we're going to make from network to from network to network? Okay. So the way you figure that out is you take that last number there is 192 and you subtract it from 256. So you take 256 and you subtract 192 and you get 64. So that's your block size. Okay. So you probably do this like easily with tabs, Scott, to show the actual breakdown, right? So
This is true.
so here you make a chart, right? And in your chart, the first number is always going to be a 0. So if you hit enter twice, go down, and you're going to do 0, then tab. Then your next jump, your next network is going to be 64. Then tab again. So what's 64 plus 64? 128.
128.
Right. So type in 128. Then you're going to tab again. What's 128 plus 64? 192.
Yeah.
Okay. Now on the next line, we're going to do our first hosts in each one of these networks. It's always whatever that number is on top plus 1. So your first number is going to be a 1. Then tab 65.
129.
That's correct.
193.
Exactly. Okay. Now the next one is going to be a little bit harder to figure out. So we're just going to hit enter and we're going to leave that space. Okay. So go down one more line, Scott. Okay. And we're going to say, okay, so the broadcast address on this is going to be one less than the first number, which is our network on the next. So you're going to put at the bottom of this 63.
63.
And I think you went down too far. You wanted to go up one space. Right. So do 6. No. Yeah, right there. 63, then a tab. Then if you look over to the right, you see it's 128. You're going to go one less to 127. Then tab. You see over, you have 192. You're going to put 191. And funny, how it always works out is 0 in the first spot. This is going to be 255. It's always going to be 255 as your last broadcast address. Now, if you move the arrow up just one, you're going to go back underneath the 1 and above the 63. You're just going to take one less than the one below it. So this is going to be 62. Then a tab, 126, tab, 190, and then 254. Okay, now what the hell did Rik just do? Okay, so here's what we're going to do. We're going to basically, I want you to put a notation. So go to the 192 and then do a tab. Okay, this line contains our networks. Okay, meaning we're going to have the 0 network, the 64 network, the 128 network, and the 192 network. Now, if you move your cursor down to next to 93 and tab again, this is your first host on that network. Okay, and then move down and tab your last host on that network. And then finally, your broadcast addresses. Okay, now the cool thing about this is we don't even care what the IP addressing scheme is. No matter if you make a 172 network, a 10 dot network, a 3 dot network, or a 200 dot network, it doesn't matter. That last octet is always going to be one of like somewhere in the ranges of these numbers. So in that first column, all the way on the left, the 0, 1, 62, 63, on our first subnet, 0 is our network, right? So let's call it 192.168. And Scott, you could type this in down at the bottom underneath the next line, right? So you can type in 192.168.5.0, right? That's our network. Okay, that's how we describe, like when we're talking about the entire network, that's our network. Okay, then 192.168.5.1 is our first host on the .0 network. Excellent. Okay, then 192.168.5.62 is our last usable host address on the .0 network, or on the 0 network, as you put. That's perfectly great. Okay, and then 192.168.5.63 is our broadcast on the 0 network. Giving us exactly 62 hosts per subnet. And you can interchange these out. So Scott, if you change the 5.0 to 5.128, right? If you just put your cursor right up there and take the 0 out and make it 128, and then 129 is your first host, and then 190 is your last, and 191 is your broadcast. Now on the 128 network, 129 is your first usable address, 190 is your last usable address, and 191 is your broadcast. And you could put those numbers in the 64 network, the 192 network. You can do this as much. You can do this to describe those networks as much as you like. Okay, because we have 4 possible networks with this with this configuration, and those are our literal IP addresses if we were going to use 192.168.5 as our network scheme, right? And you could literally, doesn't matter, if you want to do 10.10.10, 128 will be the first host, will be the network, how you refer to the entire network as a 128 network, right? So in your routing table, that would be to tell your router how to find the 128 network, okay? And hosts 129 through 190 will be on the 128 network. And if you wanted to broadcast to all hosts, you use the 191 address as the broadcast. Anybody got a question here?
So far, no.
Or did I just fucking bore everybody to death?
No, I get it. I just, I've always, how this always has been with me.
Yeah, but listen, this, as far as like lessons go, and like when I was teaching, this was like literally the hardest thing for everybody to learn, because everybody looks at numbers and they think it's math. It's not math. It's ones and zeros. I used to tell people, you want to do subnetting? You want to totally understand subnetting? Okay, could you count to 1? Start with 0 and count to 1. Then you can understand subnetting.
Yeah. I mean, it doesn't matter what you do in this.
Exactly.
It doesn't.
Now, here's what you want to kind of wrap your head around, right? If we wanted to subnet, if we wanted to borrow another bit, right? And instead of making it 192, what would be the next subnet that we could use?
1 at 128.
Let's take, Scott, do me a favor. Highlight the top 2 lines of this notepad window. The whole thing, the top 2 lines.
Oh, okay.
Thanks, bud.
Yeah.
All right. Now open up another, save that window as a subnet lesson 1. Okay. So everybody could call you and bother you for the files.
I'll
Right?
start share. I'll start sharing it.
Yeah, we can start our own website.
I'm gonna. Well, when the next cloud goes up, I'm probably gonna do that. Make a section anyway. Okay.
Now open up a new notepad file. Leave that one open.
Did I?
Right?
Oh, you
And paste.
bastard. Let's do this.
Well, you already copied it, right?
No, I didn't. I just highlighted it.
Okay.
Okay.
Right, you're gonna paste. Okay. Say enter a couple of times so we get a couple of line feeds underneath there. Right? Okay, so move that over, and we're gonna actually leave it where it is because we want to see the example on the left hand side, right? So if you go and you take the third place, you got the last octet in binary down at the bottom, right? You've got 1 1 and 6 zeros, right? Make it 1 1 1 and 5 zeros. Exactly. What does that turn that last octet into? Well, it's 128 plus 64 plus 32. 224.
Oh, damn. That's right. God damn it. Yeah.
Right?
Yes. I forgot about that. You have to add. These are zeros. This means nothing. These are the values. 64, 128, 192. Got it. Okay.
Exactly. Okay. So now we've got 5 host bits, which means we're going to have less hosts per subnet. But we're going to get a couple more subnets. Okay. So what is our first thing that we do? We go 2 to the B, right? 2 to the borrowed bits is 2 to the
3.
2 to the third. 2 to the third. Okay. And what is 2 times 2 times 2 equals?
8. Right?
Equals 8.
6. Right? Is it? No, 8.
2 times 2 is 4. Times
4
2
2
is 8. Your first knee-jerk instinct was correct. Okay.
Crazy. Yeah.
Right? So as long as you do the same calculations, you'll always come up with the right answers. Right? It's you're plugging in the same calculations, right? Okay. Yeah. So if you do the next line, you're going to do 2 to the host bits, 2 to the H, which is 2 to the 5th.
Right.
So I'll let you figure that one out.
64. Yeah, just like Captain Obvious.
I thought it was 32.
Was it? I could be wrong.
2. Let's do it. Let's do it. 2 times 2 is 4. Times 2 is 8. Times 2 is 16.
16.
Times 2 is 32.
Oh, yeah. Okay. I went a little overboard.
Okay. So, but like I said, as long as your math is right, this works every time.
Okay. These.
Okay. So the first one, that 8, that's how many subnets you're going to end up with.
Okay.
Right?
Yeah.
And 2 to the H, right, is the zeros. That's the host bits. Right? That's the second line, right? 2 to the 5th. Mm-hmm. That's your 2 to the H. Okay? But you forgot something on that. You have to do 2 to the H minus 2.
Oh, yeah. So then 30.
That's right. You're going to have 30 hosts per subnet.
Is the other two a network and broadcast.
Right? Because, you got to consider your network is your first number and your broadcast is your last. But you're going to have 8 subnets here. Okay? And then finally, you're going to figure out your block
sizes,
right? Which is 256 minus 224. 32.
Yeah. That's yeah.
So every time you jump to the next network, you're going to do 32 plus 32 plus 32 plus 32. Okay.
Right. That's right.
Okay. So let's set up our first line down in the right. Good. You get the block size in there. This is good because we're recording it. So you're going to set up your chart now. So you're going to start off with the first line is going to be 0, tab, 32.
Oh, 32. That's right. Yeah. Damn it.
Plus 32
is 64.
is 64. It's going to be your next one. Your next one's going to be 96.
6 plus 32 is
Then 128.
128, and
Then
192.
160.
Oh, 160. Yeah, right.
Then 192.
192.
Then 224. And that's it. Because your next number is 256, and there's no such thing as a 256 in our calculations.
Correct.
Okay? So on the next line, you're just going to do 1 plus every one above. And it's going to be 33, 65, and so on and so on. See how this thing just creates itself?
It does. Who'd want a network that big anyway?
Well, you might if you had the need for it, right? So hit enter twice and go down, like leaving one line open. Okay. And now you're going to take the 32 and you're going to minus 1. You're going to hit 31. And you're going to do the same thing across the board. Take that 96, make it 95, 127. Well, sorry, 127, 159, 191, 223, and 255. 255 is always going to be your lower right. 0 is always going to be your upper left. Okay, now on top of these, you just minus 1, right? So it's going to be your last toast. 62, 94, right? See how this thing just like builds itself?
Amazing.
And in case you're paying attention, and I hope you are,
Oh, yeah.
there's only a certain amount of ways to do this. So in the real world, you're only going to basically do this only to like a certain amount because your subnets are going to be small. And why would you need a subnet that small, right? Now, where would you have to do something like this? Well, I could think of military applications, like where you want to subnet things and only allow traffic, that certain traffic, like from one network to another network. You might want to compartmentalize in case, let's say you're dealing with dangerous code, right? So you don't want, if you've got a bunch of programmers building dangerous code, testing things like that. There's a lot of reasons why you might want to do this. There's one really easy thing to figure out. Most of our networks that we deal with have a subnet mask of /24. What do I mean by /24? It's how many bits there are in the subnet mask. So if you take the first, could you do me a favor, Scott, and in the in this highlight the first 3 octets? Thank you. Okay. If you add up 8 plus 8 plus 8, it's equal 24. So the CIDR notation for this network would be /24. Oh, sorry, /24, 25, /27. Okay. Because we've got 24 bits in the first 3 octets plus 3 more bits. So that would be this classless interdomain routing, the CIDR notation for this is /27, and it's just how many ones do you have? Right? Good notes, man. Really good notes.
Yeah, just like I'm trying to make it as I'm trying to dumb it down as best I can, guys,
Well,
because I am an idiot with this shit.
no. It's excellent. It's excellent because anybody looking at this video is going to be, I know my dear friend and former student Mary Beth, who was invited to this, but she couldn't go because she had already plans to go to a concert with her boyfriend Paul. And this was something that always hung her up, and this is great that you're writing all these notes. I keep on thinking about her, and like your notes are explaining everything perfectly, and thank you for that, Scott.
I'm trying.
No, you're doing a great job. Fantastic job, by the way. And again, thank you on behalf of everybody, for everybody that didn't join and everybody that did join. Thank you for lending this group your equipment to do this on. Okay.
Oh,
So that's,
yeah.
we all appreciate it. And it's good because it's making a good learning experience for you, good learning experience for a few other people who I work with and who are in our circles. Okay. So
Definitely. I mean, no problem.
the last thing I want to do with a couple of minutes left is very simply talk about, you wanted to save this as subnet lesson 2. Okay, and then open up another notepad window. And I want you to put that like right in front of both of these because I don't want to see those anymore. But I do want you to copy the top 2 lines the way you did from the first one and bring them over.
This one or the first one?
Doesn't matter. First one's fine. Okay, I'm going to make that font a little bit bigger for us. Maybe go to 20. Okay, and make that a little, center it up. Okay, so let's take away the 192 and make that a 0. Okay, and take away the 2 borrowed bits and make them zeros. Okay, now we start off with this. This is a /24 cider notation, right? And this is probably like the most common one that you'll see in the wild. Every single home network is built with this subnet mask. Most every business that small business you're ever going to encounter has got this network design, whether it be a 192 network or a 10 dot network or a 172 network, doesn't matter. Class A, Class B, Class C. You most of the time you're going to be looking at a flat network like this. Now, my question to you is, what happens when the company gets just big enough that 254 hosts just ain't enough? When you consider that everybody's connected to the wireless network with their phones, you've got the wireless access points, they're all in the same network. You've got the printers, the servers, the computers, you got a few managed switches in there. You got all these devices, and all of a sudden you start realizing you're actually hitting your head on the ceiling. 254 possible hosts just isn't enough. What do you do? What do you do? You supernet. Okay, we were talking about subnetting before. Let's stop for a second and talk about a /23 network. Okay. So if you make that up on the top /23, now what does that do to our ones and zeros? Well, if you go to the octet before and that last one, make that a 0. Okay. Now, let's talk about what that does to the network. What do you think? What do you think that does to? And now, of course, you've got to change that on the top there, on the top line. Your third 255, you're going to make that 254. Okay. Now, what do you think that does to the network? Well, if zeros are the hosts and ones are the network, this breaks up our network so that that third octet is halfway on the left side addressing the network and on the right side addressing the
Hosts.
the hosts on that network. Okay, So what I'd like you to do, Scott, is put the cursor right at the 1 0 right there. Put the cursor right in between the 1 and the 0, right? And then put a space, then a pipe character, and then a space. Okay. Now, if you move the cursor away so that it's not like in that window there, right? Like put it next to super netting, right? And move the bar, right? Okay. Now, if you look at that, right, you're basically saying that part of the third octet is talking to you about the host on this bigger network. Okay. And when I say bigger network, a /24 network has got the possibility of 254 possible hosts. If you go underneath supernetting and hit enter once, Scott, in a /24 network, you'd see, let's say 192.168.5.0 is your network, and 192.168.5.1 is your first host, and your last host would be 192.168.5.254, right? And 255 would in turn be your broadcast on that network, right? And there would be 254 possible hosts. On this network, we're grabbing like we're making that octet, the last octet that represents a host, we're making that a super number. That's not 255 anymore. Okay. You're adding, instead of 128, you're adding 256. That 0 before the dot, which is in the third octet technically, right, is giving you the 254 hosts that you originally had, plus 128, let's say 128 plus 256, which gives you the possibility of 510 possible hosts. So just by doing this little change to your subnet mask, you added the ability for your network to add 256 more hosts to your network, giving that one lone subnet the possibility of 510 possible hosts now. Now you've got tons of headroom for growth.
Now that's more like what Cablevision does, right?
Well, actually, no. Cablevision, when you look at like the cable modems, right?
Yeah.
A lot of times they try to keep it simple. They've got like your cable modem subnet mask would be 255.255.255.0, right? And they would put 254 possible cable modems on like a subnet. But in certain cases, they subnet them down to like 8 possible hosts on a subnet. They don't usually supernet. They subnet because, like, if somebody, if an attack happened, let's say, on one of those subnets, or let's say there was a disruption in the network equipment, it would only take down 254 possible customers or less,
Okay.
not more. We wouldn't want to have 510 possible hosts down, right?
Mm-hmm.
Right. So this is what you do in, let's say, a small business kind of thing that we deal with, like you deal with at UNA, we deal with over at Central. And I could point to at least 2 of our clients that we've done this with. The St. John Lynn Nursing Center, we did that. EOC of Suffolk, we did this, and Island Harvest, we did this, where we were just running out of hosts, right? So what we did is we changed that subnet mask from a standard 255.255.255.0. We made that last octet, the third octet 254.0, and turned into a /23 network, giving it 510 possible hosts. Okay. So if you go and you say, okay, like the possible addresses would be, let's say, 192.168.5, and you're done. Okay. Let's see if I can do this. 2.68.5. 4.0. Okay, so that means in the 192.168.5 network that we were discussing in the previous two notepads, right? On this network, your first address would be 192.168.4.1. And your last address would be 192.168.5.254. And your range will go all the way from 4.1 all the way to 4.255, which is not a broadcast address, by the way, okay, because it's in a supernet, right? And then it would start over on the same flat network. Your conversation is still continuing into 192.168.5.1 would be the next address, all the way to 254, right? So that range of addresses, and you could type that in down on the next line, Scott. Your range of addresses would be 192.168.4.1.
Oh, wait a minute.
It's okay, take your time.
192.168.4.1
to 192.168.5.254. Okay, and that is how your network dynamic changes by doing a supernet as opposed to a subnet, where we created subnets with smaller number of hosts broken up into distinctly separate networks. This makes one big network, which is it turns into the 192.168.4 network, okay? And it goes all the way into from 4.1 to 5.254, giving you the possibility of 510 possible hosts. Actually, there are 512 addresses here. You have to consider 192.168.4.0 is your network, right? And 192.168.5.255 is your broadcast.
So 40 is your network.
4.0 is the network, right? Whenever, like your routing table refers to how do I find the 192.168.4.0 network, I'm going to find it out this interface, right? In your routing table, right?
Yeah.
That's your network, right? And 192.168.5.255 is your broadcast on that single flat network with 510 possible hosts.
What's the math for that?
It's really simple. Think about it. Look at the number. You've got 192.168.4.1. You've got the range of 4.1 to 255. And then the very next address on the same network is 5.1. Even though the notation makes it look like they're different networks, they're not. They're the same network because of the changed subnet mask, the supernetted subnet mask.
It's up here.
That's correct. So all you got to do is, if you want to, let's say, make one flat network a little bit bigger so you can accommodate more hosts, is just borrow one of the network bits for the hosts. In the subnetting, we were borrowing host bits for the network. Borrow one of the network bits from the hosts, right? Because you're borrowing from the hosts. That's subnetting, right? Supernetting is borrowing one of, I'm sorry. You borrowed one of the network bits. Let me say this right. You're borrowing one of the network bits to add to the hosts. And that equals supernetting. Okay. And borrowing bits from the hosts to add to the network is subnetting. So the first two notepad windows that we showed you guys was subnetting, right? Borrowing from the host bits, right? And this last one where we said, okay, we've got a 254 possible host network and we want to make it a little bit bigger, right? We just took one bit away from the network side and gave it to the hosts, and that gave us 200 and 128 extra addresses, because that's actually 250. We had 256, and let's see, 128. That's 256. Sorry, give me a second. 256. It's 256. Okay, so we're adding not 128 bits. We're adding 256 to the 254 hosts that we had, and that's 510. Right? So that supernetting line with the possible hosts right underneath the binary, we have 128 plus 256. It's actually inaccurate. You're going to say it's 256 plus 254.
Yeah. Sorry.
Right? And that gives you 510 possible hosts.
Love to see the math on that one.
Yeah,
I'd
well,
love to see the block size on that.
well, so there is no block size because it's one big block. So you know what I'm saying? Like in the block size, in the block charts that we did for subnetting, that said, what was the blocks, meaning what were the networks, like define the actual networks. In this case, in the SuperNet, we've got one big block. Gotcha. SuperNetting gives you one big block in one big flat network.
And this 4 goes, it goes 4.0 to 4.250, 255.
4.0 is your network, right? Your first usable host is 4.1.
Yeah.
Right? And your last possible usable address is 5.254. Right? So that's your first usable host, right? 4.1 is your first host. And 5.254 is your last host, last usable host address, right? And 5.255 is your broadcast. So you can use every address, 4.1, 4.20, 4.50, 4.200, all the way up to 4.255. 4.255 is not a broadcast in this scenario. It would be if we were dealing with a /24 network, right? But it's not. Your 4.55 is just a host address in the network, and your 192.168.5.0 address is just another host. That's not a network address. That's correct. So your in this range of addresses goes from 4.1 to 5.254. Your 4.0 is your network, and your 5.255 is your broadcast.
Wow.
Right? So that opens up your network to be able to accommodate 510 possible hosts. And
I have to tell you, 7 years later, it makes a difference. It makes sense.
Well, you've been working with it for 7 years, bro. Right? So this is so. Next time you see like a subnet mask of 255, 255, 254.0, you know what somebody did along the way.
Yeah.
Right? They just supernetted it by one bit just to make a little more room.
Now, can you do that
from the network to give to the hosts? What were you saying?
Can you do that? You could do that again if you wanted to, right?
Oh yeah, yeah. But you don't want to do it too big again. Like you got to remember, this borrowing one bit is as far as you really want to go. I mean, maybe you could do 2 bits, okay? but you don't want to add too much, right? Because again, you've got to think about security. If you have a network
Mhm.
breach, you might want to make 4 possible subnets in this scenario, right? Once you get to the size where you've got one flat network that's that big, you might want to start saying, okay, we got to re-IP this thing, okay? And instead of having, we could probably like figure out like these 2 departments can live together over here. We've got another 2 departments over here that could live together. And we've got, the administration over here. We've got the legal department over here. You could probably figure out ways of segmenting the company into different sections, and then maybe like maybe one of those networks could be like a network that everybody has access to, and you would do that with your routing protocols. On an inside network, you would probably use OSPF, Open Shortest Path First, as your network, your routing protocol. Remember, there are 2 kinds of protocols. There are
Yeah,
routed
rip.
protocols and routing protocols, right? Your
Mhm.
RIP, your RIP2, OSPF, BGP, those are routing protocols, right? On
Mhm.
the inside of your network, one of the most common networking protocols is OSPF, which is my personal favorite protocol because I understand it the best. BGP
Mm.
is mostly used out on the internet, Border Gateway Protocol, they call it.
Mhm.
Um, and like I've almost never worked with it because I don't have any experience dealing with like working at a company that does like for like Verizon or something like that, or Optimum, right?
Right.
I've never worked in a big like outside public environment like that. We're managing IP addresses for public consumption. I've always worked for companies that had their internal networks, right? So OSPF is something I've got a lot more experience with, and I've always favored that over RIP. Or really nobody uses RIP anymore, but RIP2. RIP2 solves the problem of like split horizon and like routers getting confused about how to find different networks. Um, the it's kind of like having when you have a computer with 2 NIC cards, you
Mhm.
only want it to have one gateway, right? Because if you have 2 gateways, the routing table gets confused about which fucking gateway to use, right? Especially
Mhm.
like on a Hyper-V host where you've got like maybe 7 or 8 hosts living on there, so that the host machine sees 7 or 8 IP addresses. You only want to
Right.
have one gateway, right? So anything going outside of my little world here goes through that address and no other address. There's no contestation about that. Um, so I've just always found that OSPF is a lot easier to deal with than other routing protocols on the inside network. And that's correct. Supernetting is one big flat network, and subnetting breaks up the network into smaller, more manageable networks.
So if you were going to take all these with this one big giant network,
Mm-hmm.
and let's say you said to me like accounting and human resources can go together, you would do that through routing and doing VLANs and stuff like that, right?
Well, the VLANs, you got to remember, VLANs happen. They don't happen at the network level. They happen at the data link layer, right? So you got to think about
Right.
that OSI model again. Okay,
Mhm.
VLANs happen at the MAC address layer. Okay, where we're taking host ports on a switch and saying these 8 ports are going to be part of VLAN 0. These other 8 ports are going to be VLAN 1, and these other 8 ports are going to be VLAN 2, and these last 8 ports are going to be VLAN 3. Like as an example way to break up VLANs. VLANs and routing are 2 different things, right? Routing happens at layer 3, the network layer, right? And that's done with TCP/IP strictly. And you join those networks together or break them apart using a router as opposed to a switch. And that, of course, leads to another conversation. What about a layer 3 switch? A layer 3 switch is simply a switch that also does routing.
Mhm. Yeah.
Okay, so they said, hey, why don't we build this thing to be a layer 3 switch so we don't need routers like for our 4 networks. We can do everything inside of this one managed switch. Well, yeah, brilliant idea. And of course, they're out there. Um, so that's a whole other conversation. Perhaps for next week. We can go into like VLANs and how the difference between like the actual functionality between a router and a switch, and how they're very different and they work on a completely different layer of the OSI model.
Gotcha.
You know, that's we're already almost at 9:30, so we're a half hour over, and I think we've fried Christian and Thomas's brain.
That's fine.
Good night.
That's fine.
Yeah, good night. Yeah, good stuff. Good stuff.
What?
Yeah, that's
Okay,
fine.
so
I mean,
Tom's not even paying attention as he's talking to his girlfriend.
mm,
That's
All
my
right,
mom.
but
so guilty as charged. Don't say it. All right. So let's just wrap it up. I'm going to turn the recording off, and we'll save that when we're done recording. It's going to save it, and we'll be able to distribute it right through here in Teams.
well, don't forget to Google that to me
Yeah, I'll
because I
send that
can't.
to you to the Google Drive too, of course.
Yeah. So the other thing is we still have to. You got to run them through this whole service setup too. We may have to redo that. You said.
Oh yeah,
Remember?
I definitely want to. I mean, look,
Mm.
when we set up the servers in the AD environment,
Mm.
basically I walked you through the whole thing, right?
Yeah, I have the
So
video.
now, here's your homework. Um, Go through the first recording, right? Take some
Yeah.
notes down and destroy it and build a whole new system,
Yeah. Okay. See if
right?
I could do
And I want you to do it like you build it, and don't even uh you know if you need to ask me a question, absolutely ask. But I
that. Yeah.
want you to see I want you to see how much you could do on your own, completely, flying solo.
Yeah.
And
Yeah.
if you want to
Hold on.
wait till we're together next week, that's cool too.
That's fine.
You know,
That's fine.
it's
Yeah.
I want you to get. I walked you through all my Rickisms and my own best practices that I've learned through the years, right? Which are in the recording, right? Um, you can go back and jot some notes down as you go, right?
I plan
And
on it.
then build out, destroy those two servers, build two new ones, and start over like you're starting from scratch and say, okay, two servers are going to talk to each other. Let's do it. And this time, don't make a subdomain. Just do like scotso.local, right? What
Yeah.
you do, you built the
Well, we did do that.
hq.scotso.local,
Yeah.
right?
What do you just?
Make it
How do you
make
want
it
to do it?
simpler.
Yeah.
Yeah,
Okay. I
just
do
do
that.
scotso.local. That's fine.
Yeah. Okay.
You know?
I'm gonna keep the Cali installed too.
Yeah,
So
yeah. We'll get to Cali.
I'm
We'll
not
do
gonna
some Cali
destroy
stuff
that.
next week, without a doubt.
Yeah.
Do some
I'm not
packet
gonna destroy.
capturing and Wireshark stuff, definitely.
Yeah. I'm not gonna destroy that. I'll leave that off for a little bit.
Now,
Um.
does Christian or Thomas know who that is in the background? Don't say it, Scott.
Nope.
I won't. They don't.
I give up.
Don't
You
know
don't
who
know who
that
that
is.
is, do you?
Oh my God. I weep for the future. I'm kidding, guys. I'm kidding.
Settle down, Scott.
I'm maintaining my calm. I'm maintaining my calm. That, my friends, are two Canadian musicians known as Geddy Lee and Alex Slice, and that's Russian sitting in the back on the drums is their new drummer, Annika Niles, who replaced the dearly departed Neil Peart back in 2020. The best damn band there ever was.
Yep, them and Iron Maiden.
Yeah, I'll go with you on that. Somebody was
Yeah,
talking to me
yeah,
about that the other day.
those are my two favorites, out of the whole genre.
Somebody was telling me about that. They said to me, "That's about as hard as I go." Like I said to this person, I said, "Well, I said I would go Iron Maiden and Megadeth. That's about as far as I go."
Yeah,
Um,
I could handle Megadeth for about 15 minutes, and I have to turn back the Iron Maiden and
I'm
the Rush again.
but I like Megadeth better than I like Metallica because I think
I can't stand
he's
Metallica, and I've told you
I
why several times.
dude, the PMRC when he went on TV and did all that, that's when I lost all respect for them. And I didn't care. I didn't care about them in the first place. This just made me hate them even more. And what I did was that was when Napster was out, which those two guys on the other end of this phone do not remember.
Yeah,
But
just
what I was
you
doing,
think about it. You've got fans out there that love your band, and you're gonna go to court
yeah,
and try to have them arrested.
yeah.
You lost me, kids.
Well, that's
It's
why I said, do you? I was downloading the full discography of their music purposely on Napster. I was
I
doing it
did the same thing.
purposely. But you know
I
what I
did
was
the same
doing?
thing.
I was deleting it and re-downloading it
I
because
had
I was being a dick about it.
I had 3, maybe 4 gigabytes of MP3s of like concerts, Metallica concerts, and any kind of rare recordings that I could find, just to piss
Oh,
Lars and James off. And I was
oh
like,
yeah.
please come after me. I beg you. I dare you. I double dare you. I double dog dare you. Come after me.
Do you remember Camp
I'll
Chaos?
eviscerate you in court.
Do you
You will. You'll go home and commit suicide.
do you remember Camp Chaos cartoons?
Sure.
So you remember the Metallicops?
Yep.
Yeah, fucking Metallicops, go.
Yeah.
What?
Yeah.
Downloading Sanitarium and MP3?
Yeah. That was
Classic,
like the
classic.
weirdest shit.
That
The
was the best thing that guy ever did.
Yeah.
Camp Chaos. That was my favorite thing in the whole world.
You're good.
Yeah. Napster bad. Beer
Napster
good.
bad.
It's such a great cartoon.
Yep.
It gives me colossal chubby. Um, so yeah. So okay. So this recording is getting all set to go. I
Yep.
will get that tomorrow. The other one is like you said, I will do my best to destroy those two servers, but not after I review what we've done.
Yeah. Yeah. Yeah.
And
If you want, dude,
then,
if you want to keep them around for a little while, that's cool too. It's like eventually I'm going to want you to do that to build those two servers and get two AD servers to talk correctly and healthy. Uh,
Hmm.
but like you don't have to destroy them this week. You want to destroy them next week? That's fine too.
Yeah. Well, the other thing is too, what you don't know is that the Synology, I'm setting that as of this weekend, I'm probably going to have these ESXIs. I'm going to have this whole thing being backed up to that anyway. Because you could do that. You could use the active business app on the Synology, and you could
Uh,
set it to back that up. I do that now. The Plex machine that's running all the whole theater in the house
well,
that
that's
gets backed up religiously
a
every morning at
brilliant
5 a.m.
idea. That's awesome.
Yeah, yeah, and I have 7 backups. So if it shits the bed, I'm not going back 10 years for a backup. I just keep the last 7 for the
Right, right,
week.
right.
But in this case, I'll probably do it like once a week. I'll back up the ESXi. That is the one good thing about Synology, I'll tell you. Their backup software is freaking rock solid, bulletproof, man. Doesn't miss a trick. It's
That's
awesome.
awesome.
Yeah,
Awesome.
and it's free. It's all part of the packaging when you get the when you set it up. So, naturally I was a pig. I downloaded every app they had that was free. I said, I'll try it.
Yeah,
But
why
I
not?
don't like I don't like their cloud. I don't like it because it's again, it's their cloud. So what I'm trying to do is that's why I'm looking into Nextcloud.
Well, it's like on my customers. Like I don't have anything like that at home, obviously, but
Not in three
in
weeks.
my in at the job, anybody that's got a Synology, I'll back up with the cloud backup of the data, and it'll
Yeah,
go
you can
over
do
and
that.
tap into the Synology and just drop changes into the cloud.
Yeah, yeah, you could do that. That's what yeah, you could do Synology is pretty friendly. But the latest news about them was the fact that they were going to start making their own hard drives and making new devices that they came out with them you had to buy their drives. You couldn't just
Ouch.
slap in 5, because I use Iron Wolf. That's all I use. Those Seagates would. I'm afraid to upgrade now because I don't want it to mess up my firmware. But that I called them. They're telling me it's not going to do it. I said, all right, I'll do it. If it does, you and I are going to have a conversation.
Oh,
So what I did was with this, it's yeah, this thing is rock solid. I have not had a problem since I've had it. And it's 20, what do I have? 27, 28 terabytes right now. I have 20
excellent.
terabytes.
Excellent.
Yeah,
You maniac.
it's 5 8 terabyte drives. So I did the parity, but I did not use the RAID. I used Synology's proprietary rating system because it was better, because it had more data scrubbing on it. Because every month that Synology gets data scrubbed and it gets all cleaned up every month.
Well, that's
Automatically it
good.
does it.
That's good. No data rot.
I have none. Right now that thing is running rock solid. This thing's been running 5 years.
That's awesome. All right, dude.
So,
I am going
all
to
right, guys.
drop. You guys, everybody have a good night. And again, Scott, thank you so much. Um, and we will talk.
Yeah, man. Every week I'm down with this. Let me know.
You got it.
You can
And
use my stuff. As long as I'm getting the teaching, I don't care. I'm good.
yeah, yeah. I mean, it's like it's all good. You know, we're every, keeping our skills sharp. That's what it's all about.
Well, it's making me a better tech, and that's all I want. All
Fantastic. All right, everybody. Good night.
right,
Good
good night,
night. Good
guys.
night.
Thank you.